Welcome students to Horizontal Asymptotes, which is on page 4 of your notes. So as we discussed last week when we looked at transformations, if you have an equation that looks like this, that's in transformational form, then this number right here will tell you your horizontal asymptote. So that tells you your horizontal asymptote. But a lot of the times, you're going to see an equation that looks like a single giant fraction. So like this, in other words. So then we need to figure out how are we going to find the horizontal asymptote. So the way you do it is to find the degree, which we've talked about when we did polyroots, actually, back here when we did polyroots. Remember, degree is the biggest exponent in the numerator and denominator, and use the chart below. So here's how it goes. You're going to have your big old fraction like this, and you're going to look at the biggest exponent on top and the biggest exponent on bottom. If this one is bigger, so if this exponent is bigger, then there's going to be no horizontal asymptote on this graph, none at all. You may have what's called an oblique asymptote, which is slanted, and you won't do that unless you take pre-cal. We don't do it in this class. So you just have to know there's no horizontal asymptote. If, on the other hand, you check your two exponents, the biggest one on the numerator and denominator, and you find that they are equal, so equal exponents, then your horizontal asymptote is going to be this value here. You're going to take your coefficients, your two coefficients, and that's where your horizontal asymptote actually is. So be careful, though, that you take your coefficients right here and do not make a fraction out of the exponents. That's not what you're supposed to do. Coefficients. Then finally, you compare your biggest exponent, and you find out that this is the biggest one. Is bigger. Then that means your horizontal asymptote is at 0. It is exactly on the x-axis. So it's on the x-axis. Or it is the x-axis, rather. So let's try some. Let's see what that's going to look like. So here's our first one, which is the same example that we have above. So find the horizontal asymptote, if any, of each function below, then find the range. We're actually not going to do that for now. I want you to concentrate on the asymptotes. So I'm going to first look at my largest exponent. Now, if I have an x, then the exponent's 1. And here's 3. So 3 is bigger than 1. This is bigger. So I'm going to look and see, well, if the exponent on the bottom is bigger, then that means my horizontal asymptote is 0. So I'm just going to put HA, horizontal asymptote, y equals 0. Bam! That's it. Next one. I'm going to again look at my exponents. So I have a 5 up here and a 3 down there. So this is bigger. So if I have a bigger one in the numerator, that means I have no horizontal asymptote. Now don't put it 0. If there's no asymptote, the asymptote is not at 0, because that actually exists. Like here's your graph. Your asymptote is right here at 0. That asymptote exists. This one doesn't. It just doesn't have one. So please don't say that it's 0. Say there is no horizontal asymptote. Now, see this one. These are both just x's, so they're both x to the 1. So these are actually equal exponents. So for equal exponents, I'm going to look up here, and it looks like I have to take the coefficients and make a fraction out of them. So let's do that. I take my coefficients right there, and I have horizontal asymptote, y equals negative 2/5. And if that were possible to simplify, you'd want to simplify it, but that's already in simplest form, so we're good there. Okay, now I'm going to have this pause and ask you to try number 4, and then you can continue the video to check. All right, so these are both degree 3. The largest exponent is 3. So that means I'm going to use this method here. So equal exponents, I'm going to take my coefficients, which is 4 and 1. So my horizontal asymptote is y equals 4 over 1, which simplifies to 4.